Hello, good evening everyone. Am I audible? Hello, am I audible?
Yes, ma'am, you're audible.
Had one revision session before this, right? So what did you cover in that? Anyone can tell me? Hello. Can anyone tell me what you covered in the last revision session?
Yes, yes, yes. That's why we are here.
Okay. So I'll just start with some PYQs, right? So let's discuss one of the previous quiz one papers. Is my screen visible for everyone? Look, if you are not going to answer, it's going to be very difficult for me to understand. So anyone can just let me know if the screen is visible, then we can start.
Yes, ma'am, it's visible.
Yeah, ma'am. Mic is working.
Yes, madam. We can see the screen. Hello, we can see your screen now.
Okay, can you hear me now?
Yes, we can hear you.
Yeah, ma'am.
Okay, thanks. So let's start with this PYQ paper because I think this is better than going through concepts alone because if you practice more questions, so if we covered an entire PYQ paper, then we'll have gone through all the concepts from weeks 1 to 4, right? Okay. So first question is the following pseudocode is executed using library dataset. And what will be represent at the end of execution?
Madam, sorry to interrupt you.
Session दोबारा लिया.
There is a
Session वापस
space.
लिया.
There is a space in left and right. A little bit zooming. That's good, madam.
Okay, 1 second. Is this better?
Yeah, ma'am.
Little increase, madam. Little increase. Okay.
So library dataset means that this contains information about books, authors, right? So the pseudocode, first look at it. So we have one variable a which we have assigned the value 0 and another variable count assigned the value 0. Okay, so one more thing is that if you have any doubts in any particular questions, you can also let me know about that. Okay, first let's solve this paper, then I'll take your doubts. So then we have a while loop. So we are going to iterate through all the cards in library dataset, right? So you read the first card, and every time you read a card, count is incremented. And then there is an if condition where you check whether the author is not Kalam, right? And the language is not English. So both of these conditions have to be satisfied in order to increment A. Okay. So two conditions we have, that author should not be Kalam and language should not be English. Then we'll increment A if both these are satisfying. If not, then we'll just move on and move the card to table 2 and pick up the next card. Right. So this while loop ends here. So now you tell me, if I go through the entire deck of cards from library dataset, what will count represent when the while loop ends?
It will represent the number of books written by
No,
author.
count. Just count.
Okay. Okay. Just count. It will count just all the cards in the data set.
Right. All the cards in the dataset. And A will represent what?
Yeah, with all the cards that are not written by Kalam and not in English as well.
So I can say, since each card represents a book, I can say that number of books that are not written by Kalam and are not in English, right?
Yes, ma'am.
So after that, the while loop ends here in line 10.
Right.
Then we have in line 11 another variable called B, which stores count minus A. So what is B actually storing? Count is all the books. A is all the books that are not written by Kalam and not in English. So what is B representing?
So the number of books written by Kalam and in English or both.
Right. So either the books are written by Kalam or they are written in English, or both conditions are true. So which of these options?
D.
Number of books not written by Kalam in English. So there can be a book that is written, that is not written by Kalam, but not in English also.
I think it's D.
D,
So
ma'am.
number of books that are written by Kalam or in
Yeah.
English or both, right? So either of
Okay,
these
right.
conditions can be true or both of them together can be true. So
Right.
B is storing this, option D, correct. Okay, so this question I think has 3 marks. So this is a very easy 3 marks. Then this one. So here we are using scores dataset. Scores dataset contains student information, right? So all the marks, date of birth, town, city, sequence number, student name, all this information. At the end of execution of below pseudocode, if count 2 represents the number of male students whose physics marks are less than or equal to mathematics marks, then select the correct code fragment. So this code fragment is missing in line 4. We don't have the if conditions. So there are supposed to be 2 conditions such that count 2 will represent number of male students whose physics marks are less than or equal to maths marks. So that should be in count 2, and count 1 will get incremented with whatever we put in place of A and B. So first of all, count 2 means here whatever it is storing, those cards have gender as male and x dot physics is less than equal to x dot math. Right? These conditions are true, then it will be in count 2. Then how will count 1 be incremented? Count 2 is in the else condition. So if this is the else condition, so if A and B should be what? What are the if conditions?
Okay, so it should be either in, so A should be female and B should be X physics greater than X math.
Right. So if both of these, so if A is the gender condition, then we can say that it should be female. And B is, if we say it is the marks condition, then it should be X dot physics greater than math, right? So since these two conditions are joined by an or.
Greater than or equal to, madam?
No, equal to is here, right? Equal to will come in the else condition. See, it is written that physics marks are less than or equal to maths marks. That falls in count 2, right? So that's in the else part. So if part will contain only the greater than condition. So if either of these conditions are true, then count 1 will be incremented, or if both are true, then also count 1 will be incremented. So only case that count 2 gets incremented is when both are false, right? So when both are false, that means this condition is true then. So out of these options, which one is our answer?
Option C.
Option C. But ma'am, here, if the gender is not female, it's male, but the marks are still like physics marks are greater than mathematics, it will still go to the else statement, right?
No, since it is joined by or, so even if one of the conditions is true, only count 1 will be incremented.
No, ma'am, I'm talking about count 2.
Count 2 will be incremented when both of these are false. A and B, both conditions are false, right? Since it is an or statement.
Okay, got it.
So which option did you say? C. Gender is female and maths marks is less than physics mark. Yes, this is the correct option. Okay, in any question, if anyone has any doubts, you can ask. Okay, otherwise I'll go to the next one. So this is a bit of a bigger pseudocode. Again, that same thing, you have to identify the if statements. So following pseudocode is executed using words table. Words table contains what? Each card contains a particular word, its letter count, its part of speech, and the sequence number. Right. At the end of execution, count stores the number of pairs of nouns. Okay. Such that both nouns have either the same letter count or both end with a full stop. So that's a lot of information. First of all, count is such a variable which is present in the pseudocode. So it is supposed to store what? Number of pairs of nouns, such that both nouns have either the same letter count or both end with a full stop. That is, both are present at the end of a sentence. So choose the correct code fragment. Okay. So let's write down the conditions first. Count should store pairs, number of pairs of nouns. And what are the conditions? First condition is both have same letter count. Second is that both end with full stop. So if either of these conditions are true, then such pairs should be counted inside the count variable, right? Because it is written either or. So or statement is there. Now let's go through the code. So first we have this count variable initialized to 0. Then in the while loop, we are going through all the cards, right? So first while loop, table 1 has more rows, you pick the first card. So since here we are comparing two cards, right? Since we need two nouns to form a pair, so we'll be comparing two cards. That means there has to be a nested while, nested loop. So whenever I told you this before also, that whenever we are comparing two cards, there will always be a nested iteration, right? So first here we pick the first card, then you check whether that card that we picked is of a noun part of speech word, right? If the word is having part of speech as noun. If so, then only you will go for the nested iteration. If it is not a noun, then we don't need to worry about it anymore. We can just discard it and move to the next card, right? Because we are only checking for pairs of nouns. But if it is a noun, then you will get inside this if block, and then there is another while loop. So the same table one only you are going through. Now you will pick the next card in that table. Let's say Y. And then after you read Y, you will move it to table 3. X card, after you read it, you move it to table 2. Y card, after you read it, you move it to table 3. Okay, why we are doing this? So that none of the repetitions are there, right? Now, there is a first if statement, there is a second if statement, then count is incremented. And again, there is a third if statement inside the else block, which if true, then also count is incremented. So first tell me, what is this first if statement? What can it be?
Ma'am, can you hear me?
Yeah.
It can be also equal to noun.
Right, part of speech. Yes, Anusha, what you're saying?
Yes, ma'am. No, I was just going to say that if the first statement want to check the part of speech.
Right. So first thing we can check is that whether it is a part, if the part of speech of the card that we picked second is also noun. So this statement could be about x dot part of speech is equal to y dot part of speech, right? And if both are nouns, then it will be equated. Then there is a second if statement. What is that?
Letter count.
So here we can check. So this can be swapped. Okay. Either we can check the letter count in this, or we can check the letter count in this,
Yes.
or we can check the this other condition that ends with a full stop. So these
Full
can be
stop.
swapped between these two if statements. Anything it can be. As soon as you verify that both are nouns, then you can swap those two conditions.
So,
Let's
I have a question here. Like in statement 2, we can use both the statements, right? So we can superimpose like we can have statements that counts the letter count, that has the letter count, like X letter count equals to Y letter count, or
hmm.
X word ends with a full stop and
Yes, that is also
yeah.
possible. Okay, so then we won't need this if else block. Then one if statement will be enough. But
Mhm.
since here they have used an if else block, so we can tell that they have separated the conditions,
Yeah.
right?
Okay.
So here if I choose to put part of speech first in the first if condition, if it becomes true, then one of the conditions is true and both are nouns, so I can increment count. If the part of speech is, I'm sorry, part of speech is in this one, so the second if this is checking for letter count. If x dot letter count is same as y dot letter count. Okay. So if letter count is equal, then we can increment. If letter count is not equal, then we can go to the else part and then check another if statement. Okay, this is the nested L. This is the else of this if statement, inner if. So inside that there is another if statement. So here we can check what the other condition, that if x ends with full stop
Ma'am, both have
and y
yeah.
and y also. Okay, if both these are true, then I can also increment count. So if either of these conditions are true. But one thing to be noted here is that why we cannot use that. Someone said na, that we can write this in a single statement. Now, why we can't do it here? Because here they are asking that either they have the same letter count or they both end with a full stop. They didn't say that if both conditions are true, then you cannot have it. Okay.
Yeah, exactly. So that's why we need to go for the other else iteration, right?
Yeah.
Yeah.
So at a time, only one of the conditions should be true.
But we could if the question would have been the following way, that there would have been this this third statement, this third loop that would not have been there, and instead we could have put this statement, the X LOC equals to Y LOC, and put it with a Boolean statement of OR with the third statement.
But whenever you put or, then it counts that both possibility also, no? Or is true when both are true also.
Yes. Okay. Yeah.
So that's why you cannot do this without an if else. Okay, one line this cannot be done. Okay, so if I check the second if statement here and if I check the full stop condition here, if that is also true for some, then I can increment count here also. So based on this, which of these options? Let's take the first option. So it is saying that first statement should be part of speech. So that is true. This first if statement should check the part of speech, whether both are noun or not. Then only we'll check further. Then second if statement is checking whether letter count is equal to a y letter count. And then third if it's checking whether both words end with a full stop or not. So is this a correct one?
Yes, ma'am.
Yes.
Okay. Let's see the others also. So the second one is first putting that X word and Y word end with a full stop. But first we have to check whether they're both nouns or not, right? Because we're looking for pairs of nouns. So the first if statement cannot be this. So this is wrong. Third option is checking letter count first. Again, you have to check the part of speech first. This is also wrong.
The
In the
first,
D option is also
so
same thing.
the first statement ending with full stop. So that means if you are collecting that data, other two data it's not covered, right? So in that,
No,
so
I mean in the first if statement, that is here if you put that X and Y end with a full stop. So you're
okay,
imposing that condition. You're not even checking if both are nouns. You
yeah,
only know X is a noun. You don't know whether Y is a noun.
okay,
Okay, but the condition is what? We are looking for pairs of nouns which have either of these conditions as true.
okay, okay. So in the year the order is matters, right?
Yes, here the order will matter. First you check if both are nouns, then you put the other conditions. Because if Y is not a noun, then there is no need to check the other two conditions, right?
Understood.
So, okay. So for D also, you can see first statement is checking the letter count. The first statement is part of speech only for option A. So option A is true. Okay, answer is A. Any other doubt from this question?
Ma'am, one doubt. I just joined late. Ma'am, this 3 stars. What does?
See, this question is asking that we, in this count variable, we store the number of pairs of nouns such that both nouns have either the same letter count or both end with a full stop. So these three if conditions are vacant. We have to fill in the statements. Okay, so since we are looking for pairs of nouns, that means we need to check two cards at a time. We need to compare. So there will be a nested loop, right? So there is a nested while loop inside the outer while. So first we check whether the first card that we pick from the dataset, whether it's a noun or not. If it is a noun, then we will go into the nested iteration, pick one more card. And then in the first if statement, we will check whether these two have the same part of speech. Because if both are nouns, only then we will check the further conditions. If one of them, if Y is not a noun, then no need to check the other conditions, right? Then you can just pick the next card in the next iteration. So if we find X and Y such cards, which are both nouns, then we will check these two conditions. Okay, the first if condition might check that whether their letter count is same. If it is true, then you increment count by 1. If letter count is not same, then you come to the else part and check one more condition, that whether both end with a full stop. If that is true, then also you increment count. But at a time, any one of these conditions should be true, right? Both should not be true.
Okay.
Okay.
Ma'am, can you give some example? Question number.
Example, let's say you have two cards. Maybe one of them has someone's name, right? And one of them has a city's name. So this is your X card that you pick. Okay. So if you pick the, let's say this one ends with a full stop, that is this card that you pick is at the end of a sentence. This one also ends with a full stop. Both are at the end of two separate sentences. Now first, this is the X card, this is the Y card. So you pick X, you check whether X is a noun. Yes, this is someone's name, it's a noun. So next you go to this while loop, inner while. So inner while loop also iterates through the same table only, okay. But we have removed the X card from that table so that we don't pick that same card twice. So now this inner while loop will iterate through all of the other cards, okay, to find such pairs, all of the other cards. So let's say the first card that I pick is this card Y with this Kolkata as the last word in a sentence and it ends with a full stop. So now since both are nouns, so you come to this if condition in line 9 and you check whether both part of speech are same. So part of speech will be equal both nouns. Then you go to the nested if. In statement 2, now you will check whether the letter count is same. Is the letter count same for X and Y? No, right? This is
No.
3 letters, this is 7 letters. So this won't work. So you go to the else part. You check if both of them end with a full stop. So both of them have full stops at the end. So this is true. So you can increment count. Similarly, if you find two nouns which have the same letter count, but one is at the end of a sentence, another one is not, then also you can increment count.
Okay, ma'am. Thanks.
Okay. So this question is saying following pseudocode again from scores dataset at the end of execution, count captures the number of students whose total marks are more than the class average of total marks, but have scored below the average in at least one subject. So two things we know, that count will capture those students whose total marks are more than the class average of total marks, but they have scored below the subject's average in at least one of the subjects, right? So assume that the variable avgt, so this variable average t, it holds the value of average total marks of entire class. Similarly, average p holds the average physics marks of entire class, average chemistry marks, average maths marks, right? So you have to choose the correct code fragment to implement the pseudocode such that count counts these conditions. So initially count is assigned 0. Now you pick up first card from table 1, that is your sports data set. Now A, B, C, and D will be set to false at the beginning of every iteration. Okay. Then in line 5, your first if condition is checking whether the person whose card you have picked, whatever his total marks is. Right? Okay, let's just take an example. Let's say average total marks of the class is 220. Average physics marks, let's say, is 70.
And what is
Average
X total? Is the class average?
average total is the class average. X total is the person whose card you have picked, their total marks.
Okay.
Okay.
Ma'am,
Average C, yeah.
ma'am, so here for count to be incremented, A has to be true or and B or C or D.
Right.
Because okay.
So
Ma'am, what
average,
does A, B, C, D represent here?
I'll tell you. Okay, first let's consider an example. Average P, let's say average physics marks of entire class is 70, average chemistry marks is 60. Let's say average maths marks is 65. Okay. Now let's say some person's card I have picked whose name is X. So that person has scored an average of, I'm sorry, not average. That person has scored, let's say, a total of 230. Okay. Now his physics marks, let's say his physics marks is, how can we break down 230 in such a way? Okay, let's say his physics marks is 72. Chemistry marks is, what can we put? Okay, let's say if in math he has scored below average, maybe he scored 60 in math. So 60 plus 72 is
75.
giving 132. That means he scored 98 in chemistry. Right? Is this correct calculation? 132?
Correct.
98.
Yes, correct.
So if this is the example, then first for every iteration, that is every card you pick, A, B, C, D will be set to false. Now first condition will check whether his average is greater than total average of entire class. Yes, 230 greater than 220. A is set to true. Next, line 8, you are checking whether his mathematics marks is less than class average, because he has to score less than subject average in at least one subject. It can be more than one. Okay, at least one. So mathematics marks is, he has scored 60, maths is 65. So B will be set to true. He has scored less than class average in math. Then line 11, check his physics marks. Is it less than class average? Physics, he has scored 72. No, it's not less. So C will remain false. Again, line 14, check for chemistry. He has scored 98. Average is 60. So also D will remain
CD.
false. That means he has only scored less than average in math. But our conditions are now true, right? He has scored greater than the average of total marks in class. But at least in one subject, he has scored less than class average. So now what is the snippet of code that we need to fill in here to make sure that count captures this card? So you see, these are your options. Okay, first let's go one by one. So for this particular student, we know A is true, B is true, C is false, D is false. So if this is the condition, is this going to increment count? So first inside the bracket C, these two are conditions. Since these are OR conditions, that means if any of them is true, the whole thing will evaluate to true.
True.
Right? So inside this, it will evaluate to true. And A is also true. So both are true, then count is incremented.
True.
But now let's say for some person, if he has scored greater than class average total mark, but less than class average in every subject wise, then will it be true? No.
No.
If B, C, and D are all false, that means it will give a false result. So it's correct. It is keeping up with my conditions. Now, even if this is the correct option, if it is an MSQ, we have to check all of them.
Madam, in this options, after and B, C, and D, here any two is false and one is true also, it will come as true, right?
Right. Unless and until all three, B and C and D, are all false.
False. Okay.
Only then it will be false.
Then that time it will be false. Okay.
Yes. Okay. Now see, if second option is saying A, so our A value is true, or condition is there. So B is true, C is false, and D is also false. But here, since and is present, so what will this entire thing evaluate to? False.
False only.
Now, true or false will give what?
False.
False.
So
True.
count will be incremented.
No.
No.
True or false will give true, right? It is or condition.
Yes, ma'am.
Okay. Yes.
So count will be incremented. In this case, it works fine. But see this, if all three were false, if he scored below average in every subject, right? Then what will happen?
Count will increase. Yeah.
So true or false again. Now, since our condition is that at least one subject, that means that person may have scored less than class average in all three subjects also. Then also they should be counted, right? That's our condition. See, the question says that total marks are more than class average, but have scored below subject average in at least one. At least one means more than one is also possible. In the first option that we saw, if here it was all false, then we'll count this card. True and false will give false. So is this a correct option?
No.
Option A is correct, you said. But for all false condition, it is not going to count because and condition is there. True and false will give false.
Yeah, because my second condition would not be satisfied, right?
Yes.
Because yeah.
So A is not a correct option. You have to check all the possible cases. Okay. If your one
Means
example,
at least one subject below the at least
you
one
have to
subject
check
below the
for
average.
one subject
Below
and
the
you have to
average.
check for all subjects also. If all
So
subjects are below average.
yeah. So
Right.
so in
So
this
A
case
is
it's
not
false.
correct.
Yeah.
Now, in second case, we saw that if all three are false, that is, he has scored below average in all three, but he has scored greater than total average. So, if this is the case, then also true or false will give true, so count will be incremented, right? So, when will count not be incremented here? When, since odd is present, so both have to be false, right? So, if A is also false, only in that case, if A is false and B, C, and D, any one of them are false. So, false or false will give you false. But that's not what we are looking for, right? If A is false, then we are not going to check the other conditions because first
Yes.
condition is what, that
Yes.
average should be greater.
Yes.
So is this a correct option?
No.
Check very carefully. Let me check also again. So if A is, in our case, B is true, A is true, but other two are false. So true or false will give true. If this is okay, then
True,
what happens
false.
if this person has scored
Ma'am, A is not correct. I thought it was A and B or
second. I think we are messing something up about the true and false. See,
because you need at
true
least
will,
one subject.
yes. So true will happen when the total, when the subject marks is less than average, then it is true. Right. So in our
Yes.
example, A was true,
Yes.
B was what? Maths is less than subject average, so B was true, C was false, D was false. If someone scores less than subject average in all three subjects, then B, C, D, all are going to be true. Right. So what are the cases that are permitted to us? First is that A has to be true and B can be true, C and D can be false. This is one case that is allowed for us. Right. Another case that is allowed is A has to be true and let's say B is false, but A and C are true. This can also happen. So there are a lot of combinations which are allowed. The only combination that is not allowed is that A is true and all of ABC are false. That is not allowed, right? At least one of them has to be true. So if we put this condition here, so B is true, C is false, D is false. In that case, count will be incremented.
Yes.
If both
Because
of them are
or
true,
there is no matter, because or is there. If anyone is true, then it
A
will
will be
increment.
correct. Because if all of these are false, that is the only case when count will not be incremented, right? Because or condition is there. So A is correct. But then what about the other options? If I apply this case to here, if all three are false, then is it counting still?
No,
False, false,
it
false
won't
will
count
give false. But
Because our
will
second
count. See,
condition is, but our
this
because
second
A
condition is
is,
violated, no?
B, C, D, one condition must be true.
yeah, but all are false and A is true. That means total average is still greater. But
Yes,
we need at least one of them to be true also, right?
true.
Only then it should count. But if here all are false, then also it will count because true or false will give true.
No, but B from B, C, D, one must be true.
Yeah, that's why this option is wrong. Because it will
Ma'am,
increment count. BCD
Yes,
all are false.
B is wrong.
correct.
ma'am, also because if B or C or D, if any one of them is false, the answer will come out to be false, right? So no
No, there
matter
is or
which,
condition.
yeah.
There is our condition.
So if A
I'm
is
talking
true,
about B, C, D.
Yeah,
okay,
I
yeah,
get it.
With the
BCD,
and
if any one
condition.
of them is false, it will come out to be false.
Okay.
Yeah. But in this case, our checking condition is what? That if all are false, that is the case that we don't want. So if all are false, in that case also it is incrementing count. So B option is also wrong. C option is saying, okay, let's put that base case here also. If A is true and all are false, is it still counting? So inside, since AND operator is
And
there,
not
all
is
false
there.
will give false. But there is a
Yes,
not.
yes, yes.
So not of false is true. And true will give true. So this is also wrong condition. Understood why this is wrong? Because B, C, and D can all be false. That means he has not scored below average in any of the
Yeah, because
individual subjects.
yeah, exactly. Because our second condition gets violated from here.
Yeah. So since this not is present, even though this will evaluate to false, it will turn it into true. And true will increment count. So this is also wrong. Last option, it is saying A. A is true or not of B or C or D. If all are false. In that case, what happens? Or will give false output. But
Yeah,
again, not is present. So not of false is true. So this case also it will increment count. This is also wrong. Option A is the answer. Okay. Is this clear?
Yes.
Okay. So this type of question, see, best way to find out which one is the correct one is that you take the case that we don't want. That when will we not increment count? Will not increment when A is either A is true and all of BCD are false, or A is false. If A is false, then we don't need to check anything else.
No, nothing.
Okay.
Madam, these questions you just collected from the previous
Yeah, this is
year
just a
question.
previous term paper for quiz
Okay,
one.
okay.
This is not mock one.
No, this is not more. Okay, next is this one. So following pseudocode is executed using words dataset. What will A represent at the end of execution? So first we have this sum. Okay. Just give me a second. Yeah. So this is also executed on words dataset. So what will A represent at the end, that we have to find out. So all the code is there. You don't have to write the snippet. Just identify what is A representing. Right. So sum is initially sum of T is set to 0. Count T is set to 0. B is set to 0. Then we have the first while loop. So this one goes through all the cards in the words dataset. So you read the first card. Every time you read a card, you increment count T by 1. Okay. And sum of T is storing what? It is adding all the letter counts of the card. Once you have read a card, incremented count and sum, you move it to table 2. So like this, you do this entire loop till line 7. And when the condition is exhausted, that is, you have gone through all the cards. So at the end of this line 7, what information do I have? Count T has stored what? Number of cards in words dataset. What
so
has
B
sum t stored?
stores the average count, right? The average number of cards that we are seeing.
Sum of t stores just the sum of letter counts. B stores the average.
Yeah.
Yeah. B stores the average letter count.
Yeah,
So
exactly.
this is average letter count. Now in line 10, we have more variables. So sum of S is 0, count S is 0, A is 0, C is 0. Then we have one more while loop. Now it is going through table 2 rows because table 2 now has all the original cards from table 1, right? So you go through all of those cards in table 2. So you pick up a card, count S is incremented, sum of S is incremented using the letter count, right? So sum of S is storing again sum of letter counts, and count S is storing again the number of cards. Then you have one more if condition in line 15. It is checking whether the current card that you are holding is a word that ends with a full stop. That you have reached the end of a sentence or not. Right. If you have, then C is going to store at that point sum of S by count of S. So what is this?
The average letter count in a sentence.
Correct. So average letter count in a particular sentence. Then if C is less than B, then A is incremented. So what am I checking? Whether a
Average is
particular
less than B.
sentence, yeah,
The
in a particular
average
sentence,
letter count in a sentence is lesser than the average letter count in the whole words paragraph.
correct. So if that condition is true, then A will be incremented. Right. So A is storing what?
Storing the
See, after this if condition, sum and count are both set to 0 again. Right. But see one thing, is C ever reset to 0?
What, ma'am?
No.
Sum and count are reset to 0, fine. But is C being reset to 0?
No.
the C cannot be reset to 0 because when the paragraph, because once the sentence ends, you cannot reset the C because C counts the average letter count in that sentence, right?
Ma'am, but C will be updated, no?
C will be updated. It is not reset to 0, but in line 16, it will get updated automatically
With every
if the
sentence.
condition is true. Yeah.
Yeah.
At the end of every sentence, C will get updated. But I would still say that it's a good practice if you just put a C equals to 0 here. It's a cleaner code. That okay, we are resetting all the variables. Anyways, it is not here, so
Way more easier.
yeah. So what is this entire loop doing, this while loop? So we are going through every sentence. At the end of every sentence, we are checking whether the average letter count of this sentence is less than the average letter count of the entire set or not. If so, then it will increment A. That means A is counting number of sentences. Number of sentences what? Having?
Number of sentences having lesser average letter
count than the
than
entire
the
paragraph.
whole paragraph, yeah.
The average letter count less than total average letter count.
Yeah.
So that is our question, right? That what is A representing? So which option will be correct?
B.
Okay, so number of sentences with average letter count less than average letter count of dataset. What are the other options? The first option is saying more than the average letter count. This is wrong. Number of words with average letter count. We are checking for sentences. This is also wrong. And number of words with average letter count less. Again, for words we are not checking. So option B is correct. Okay, this is a good question. This one, procedure miniSum. So some procedure called miniSum, it accepts 3 numbers as parameters and returns the sum of the 2 smallest numbers. Okay. But nowhere it is mentioned that the numbers all have to be distinct, right? So that's one thing. Anyway, for example, let's say I have 3 distinct numbers, 2, 3, and 4. If I pass these as parameters, that is A is 2, B is 3, C is 4. Okay. Then this procedure, according to the definition, should give me the sum 5, right? 2 plus 3, two smallest numbers, sum. So how is it doing that? First, we have sum variable, obviously, to store the sum. Then in line 3, we are checking whether A is less than C and A is less than B. I'm sorry, A is greater than C and A is greater than B. So that would establish that A is the biggest number, right? So we can discard it and sum can store B plus C, the 2 smallest numbers. But this is just one condition. So we have to check this condition for B and C also, right? So which one of these codes will be correct? First option is saying that in the else part we can check if B is greater than C and B is greater than A, then sum will be
And
A
can you
plus
repeat
C.
what we have to check?
We have to, this procedure find miniSum. So if we pass three numbers, it finds the sum of the two smallest ones.
Okay.
Okay,
So
so
what
in
we
the
have to
first
check?
if condition, we have checked that whether A is greater than C and A is greater than B. That is, if
Hmm.
A is greater than both B and C, so A will be the largest number. So we can discard it and take the other two numbers and take their sum. Right,
Okay.
so B and C.
Okay, so
But we have to check this condition for all of them.
okay, so
What?
basically we are checking the first number with every other number, right? For each number we are checking whether that number is greater
Greater
than
than
or
the other
less.
two numbers.
Yeah,
Hmm.
Yes.
exactly.
So we can write it next else condition can be what? So in the else condition, first option is saying we can write if B is greater than C, B is greater than A. That is, if B is the largest number, then find the sum of A plus C. If both of these are wrong, that is neither A nor B are the largest number, that means C has to be the largest. So in that case, sum should be of A and B. Right. So else part has A and B. So is this correct?
No, ma'am.
Yes.
No.
Anyone is saying no?
Yes, ma'am, it's
Yes,
correct.
ma'am, it's correct.
This
Yes,
looks
ma'am.
correct so far. Well, let's check the other options, what is
Other
wrong.
option first.
So here we have an if else, right? But the second option says that we just put a simple if condition and check again. That is B
I
greater than
think
C, B
second.
greater than A.
Hmm.
Then we do A plus C. Okay.
Can I check the first code above one? Or above more question? No, ma'am. Else one is correct.
Why else one is correct?
Because if is there, if cannot be.
But we can put if one if after another, right? There is nothing wrong with
Ma'am,
that.
can you just explain with the examples you took?
Hmm.
Okay, let's say we
Make
took
it
2, 3, and 4, right?
Yeah.
So if I put this in the first if condition, 2 greater than 4, 2 greater than 3. Both are wrong, right? So according to first option, I will come to the else part. Then check is B greater than C, that is 3 greater than 4. Again, violation. So you go to the else here, inner else.
Hmm.
So you find the sum of A plus B, that is 2 plus 3, it is giving me 5. Fine, this is the desired output. But what happens if I put it here? So the first if is violating. Now second if, instead of else, I'm using just another if statement. So here also I will check is 3 greater than 4, is 3 greater than 2. So one is correct, one is wrong, but AND operation is there. That means the whole thing becomes false. So then
Above
there is an
also
else.
AND operation.
Yeah, above also AND operation. This also violates. That's why we came to the else part.
Okay.
So then we have one more else statement which says find sum of A plus B. So this will also give 2 plus 3, 5.
Same.
So both are working, we can see. Okay, let's check the other option. C. So first if is violated, then they are saying that we have an else. So directly they are finding 2 plus 3.
Some.
But this, for this particular one, it will work. Okay. For this particular example, it is working. But if I change the example, okay, let's say my example is
That condition, the else is given first, then coming if. So how it will look actually in the program actually.
so this if it is violated, it will go to the else part.
No. The last option you showed, no. So that
Yeah,
one
that's what I'm
first.
saying. This
Yeah.
else is for the first if that is given in the actual code.
Normally after if else will come after if only, right?
Yeah, see, there is an if now. Here in the original part, there is an if in line 3. So after that, if I put an else, it's fine.
Okay.
I can start with an else.
Okay.
And we
Understood.
can start if also.
Yeah, we can start if also. Everything is allowed. So
Okay.
let's take a different example. If I say A, B, and C are 9, 8, and 7. In this case, what happens? First, if I'm checking, okay, let's change this here.
9 is
So we'll get the
greater
answer in
than
the
8.
first step. Okay, let's do 8, 9, 7. In this case, what happens is is
8
A
is
greater than C?
no.
A is greater
Yes.
than C. Fine.
Yes.
Is A greater than B? No.
No.
So for this, if I go to this option, right, it will go to the else part and it's telling me to directly add A and B. But if I add A and B in this case, it is 8 plus 9, 17.
Hmm.
But what is my two smallest numbers? 7 and 8. The sum should be 15,
Hmm.
right? So option C is wrong. It is going to give a wrong answer for this. Whatever combination of ABC I take, my correct code snippet should always give me the sum of the smallest two.
Smallest.
Ma'am, why is the option B not correct?
Option B also, see, if I take, I haven't said if it is not correct. Currently, for our present example, we saw it is correct. Now let's take this different example where B is the highest one. Okay, in this case, first if is violated. Now if in option B I go and check, okay, B is 9, A is 8, and C is 7. So is 9 greater than 8 and 9 greater than 7? Yes. So if both of these are true, then you add A and C, that is 7 and 8, 15. For this example also it works. So when A was the highest one, I'm sorry, when C was the highest one, then also it worked. When B was the highest one, then also it worked. Will it work if A is the highest? Yes. Because if A is highest, then in first if condition only will get the sum.
Yes, ma'am.
Right. So B option is correct. In
Both
A
A and B
option,
are
if
correct.
I do, A option will also give the correct sum. C is definitely wrong. D,
And D is also.
okay, the answer is just A. That means B, for some condition, B will give a wrong outcome.
Yeah, I think that is if condition.
Ma'am, maybe because if we are using different if statements, then we
Yes,
cannot
yes.
use the else
Same if.
statement in this. I think.
So in first line if,
So
second
you're
also
saying
if.
that because of the first two are if statements, so the else will be confused on
Yes,
what
yes.
Yes,
statement
First
is
one.
ma'am.
else. Okay. But
Maybe.
did we check with all three possible conditions? We checked for 8, 9, 7, it is giving correct. 2, 3, 4, it is giving correct. Also, if I take 9, 8, 7, then also it will give correct. So where will it give the wrong answer? If I have two equals condition, we are not checking anywhere.
Because
So
there
why
is
is
no
option?
there, because A and B cannot be unique or B and C because either of those two cannot be unique, right? So we are not
But
checking.
it is not mentioned in the statement that all have to be distinct. I guess we have to assume that all are distinct. But if I take any of the three cases, whether A is the greatest, B is the greatest, C is the greatest, option B is giving the correct sum, right? So how is it wrong? Okay, let's check the example one more time. So if A is 2, B is 3, and C is 4.
It is not included in else condition.
Yeah, that is the only thing we have that this is how we can say that it's wrong since the else is not proper. That is, I don't know what if statement this else belongs to. But still, let's check with the options again. ABC, if it is 2, 3, 4, then what happened? First, if condition is violated, if I pick the option B, then 3 greater than 4, 3 greater than 2. This is also violated. We found sum of 2 plus 3. Fine. If A was the highest one, A9, B8, and C7,
Ma'am, then it will be true in
then
the
only this
condition only.
first one is only
Yeah.
true. Yeah, correct. Okay, what happens is, see, since we have two if statements, right? So if this is correct, then also we are going to the next statement. Am I changing the sum anywhere? No,
No.
still also it works. Okay, let's take this example,
Ma'am,
9, 8,
ma'am, I
7.
guess you said it right. If the first statement is the statement which is in the third line is correct, then again we are also going to the next if statement and checking it. Maybe
Yeah,
that's
but even if we check it, it is still violating. We are not updating sum. Sum will remain correct only, right?
yeah, ma'am.
But if I take this example where B is the largest, then the first if condition fails. Now, second if condition, B will be large. So A plus C. It is giving correct in all three.
Ma'am, in the C, even if we go to the else statement, else is saying directly add the sum A plus B. And then do
C
we need
option,
to again do the if condition C greater than B?
C is definitely wrong. I am checking whether why B is wrong. Because B is giving correct answer for all the sequences. So how is B wrong?
Ma'am, B is
Okay.
not wrong
Yeah, that's what I think also. Okay,
because
one more
in
thing.
I have worked in Java
So,
where
this
we
I have
can
a,
use
Can you
multiple
please
if
show me
and
questions once
only
again?
the last case should be else part. Then also the syntax is true.
Yeah, because it will, default it will take like this, that this last else is of this if.
Yes, ma'am.
That's
When we
how
use
it works.
multiple if, then at the end there should be at least one else case.
Yeah.
Then the syntax is true.
So there are two ifs and there is one else case. So even if the else case is taking what the sum of A plus B, that means this will only execute when C is the greatest. So this is very valid. In the first if we are checking whether A is greatest, second if we are checking whether B is greatest. So third if obviously C has to be greatest, third else statement. I think B is correct. I don't find anything wrong with this option. I think both A and B are correct. A is definitely correct, but what is the difference
Closing
between A
bracket
and B?
in B is not starting bracket, right?
It's the brackets.
Starting bracket B. Look, there is no starting bracket for if statement.
If statement doesn't require starting bracket. There is no such thing. Inside the if, you should have a starting bracket that is here and here, start and close. That is okay. So the difference between these two statements, A and B, these two statements, is that A is inside an else block, B is not inside an else block. That's the only difference. But will it change anything if I take
Ma'am,
the else block? Anyways,
ma'am,
I'm
here,
going to go to the next step.
ma'am, if we either if, instead of three numbers, if we have four numbers, then the second case won't work.
Yeah, that then there will be one more
Then
variable to check
first case won't
entirely.
work. First case won't work because it
Then
is
there is an
directly
entire variable, and then you have
from
D also.
if to else part. And option B is multiple if part and then the else part.
So only difference between A and B is that A is enclosed inside an else statement and B is not enclosed inside an else statement. But that does not really matter here.
Yes.
According to me, both should be true. Okay, let me discuss this problem once. Do you have one more session tomorrow also for CT? Is this the last session before quiz one qualifier, or do you have one more session? Anyone knows?
Tomorrow one class is fun.
Tomorrow.
Okay. I think Piyush sir is going to take that class, so I'll tell him about this question. 2, 6. Okay, let's see. I think both are correct. This is obviously wrong because in the else part only you have A plus B. So we are not even checking for the other cases. This is wrong.
There is TA session also tomorrow.
Okay.
Ma'am, I had questions from a practice assignment. Can you please help me?
Yeah, I'll take all the doubts. Just let me finish this paper, then I'll do the doubts. Okay. Okay, let's not waste time. Let's do the other question. I'll ask this to Piyush sir to discuss it once. The following pseudocode is executed using sports dataset. What will A represent at the end? So again, let's just check. So first A is assigned to 0. Then we are going through all the cards in sports dataset. Read the top card. Then there is some procedure called is in sequence of X. X is the parameter. So whatever card we are picking, we are passing it through this procedure. So what does this procedure do? Whatever it returns will be returned back here in line 4. Okay. So let's say I picked some card X, I put it in as parameter in this procedure. So we will check whether the maths marks of that student is greater than physics marks and physics marks is less than chemistry marks. Then it will return 1, otherwise it will return 0. So by this, what can we tell? If maths is greater than physics and physics is less than chemistry.
So the number of students who have got the lowest marks in physics.
So only thing we can tell from certainty here is that physics is the lowest. We cannot tell whether chemistry is highest or math is highest. Only thing we know is physics is lowest. So number of students who have scored lowest marks in physics. So every time we find such a card where physics is the lowest among all three scores, it will return 1. So that 1 will be added here. So A will be incremented whenever we find such a card where the student has the lowest marks in physics. Right. So which option?
Ma'am, suppose there is more than one student who has scored the lowest marks in physics.
It
Yeah,
would
then
Also
also.
then also it will return one, and then again
See,
will
this
the A
in
be
sequence
incremented?
X is just for a particular student, no? So we are
Yeah.
taking one student's card and checking that whether he has scored less in physics than in chemistry and math. That is, among his scores, physics is the lowest.
And ma'am, no ma'am, my question was that once we checked the a particular individual's card, then only we will increment A.
Right.
And then again, if the next individual holds the condition, all the if condition true, then again we will return one, and
Yeah.
again A will be incremented like that.
Yeah. As many times as you find such a card where physics is lowest mark, you will increment A. So
Okay.
A is going to store what? Which option is correct?
D.
D is
Number
correct.
of students with lowest
With
marks.
lowest marks in physics among 3 subjects.
3 subjects.
D is correct. This is pretty easy. This one. Following pseudocode is based on Olympics dataset. Okay, so this has information about players, what medals they have won in what year, how many medals, all this information is there. So procedure do something does what? It accepts a table of rows which contains rows of the same player. Okay, that means information about the same player is present in different rows. Now assume that the player has won at least 2 medals and only 1 medal in any year. Okay, that means in a particular year he has won only 1 medal, but all over he has won at least 2. That means the data is spanned over a number of years, right? At least 2 he
Time
has to
series.
have, there should be at least 2 rows in the table then. So what will B minus A represent? Okay, let's see that code. So procedure do
Minimum
something.
medal.
Okay, let's solve first. So do something takes the table T1, right? That is your Olympics data set. So
Ma'am, what do they mean by the rows of the same player? Means they are from the same sports.
no, it means that see, do something accepts a table of rows which contain rows of the same player. That means maybe information about that player in let's say year 2010, then 2011 is in a separate row, 2012 is in a separate
Name.
row. Okay, of the same players. That is, in this year he has won this number of medals. This year he hasn't won any medal, like this. So if we pass one such table T1, okay, in do something procedure. So this T1 contains what? Rows about the same player. It is not the entire data set. Okay.
Mm.
This is just a table containing information about the same player. So first we have A set to 2030, B also set to 2030. So just by looking at this, you can tell that we have put some maximum year, right, in both of these variables. Then while table 1 has more rows, so now you go through all of the rows. So pick the first row, check if the year in that particular row is less than A, right? If the year is less than A, that is 2030, then you assign B to A. That means B is now what? 2030 only, since A initially stored 2030. This is the first iteration, let's say. So B will be 2030 at this point, and A will be whatever the year is on the first row. Let's say the year is 2010. Okay. So, okay, let me just make some rows. Maybe the first row is for year 2010, then for 2011. Let's say he has 4 rows, 2012, 2013. Okay. Let's say he has won a medal in 2011, 2012, and 10 and 2011, 2013,
Youth.
and 10 and 12, he hasn't won any medals. If this is the case, because he can win at most 1 medal in a year. So only 1 medal in any year, not more than one. And assume that the player has won at least 2 medals, right?
There, one medal must be there in 1 year.
No. It is saying that player has won at least 2 medals and
In
only
one,
1 medal in any year. That means he can either have exactly 1 medal in a year or no medal.
at least 2 medal in every year. It means
No. I
दो
think
medal तो
it means assume the player has won at least 2 medals overall and only one in any year.
okay.
Okay.
Okay,
So let's say
okay.
2011, 2013, he has won 1 medals, and 2010 and 12, he hasn't won anything. Now, first row is 2010. So Z dot here is 2010, A is 2030. So the condition is fulfilled. So B will be reassigned to whatever A was storing previously, which is 2030. A will be reassigned to the current year, that is 2010. Then go to the next if. Z dot here is greater than A, that is. So once we have reassigned it, Z dot here is still 2010 and now A is also 2010. So this if statement won't do anything, right? This condition is violating since there is an AND. 2010 is not greater than 2010. So this is wrong. So you move this Z row to a separate table. Now for the next iteration, go to second row. Here is 2011. Currently A is what? 2010. So Z dot here is 2011. Is 2011 less than A?
No.
Is 2011 less than 2010?
No.
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 That if.
So go to the next if.
Yeah.
Is 2011 greater than 2010? Yes.
Yes.
Is 2011 less than 2030?
Yes.
Yes. So B will be assigned to what? 2011. Move it to separate table. Now come to the third row, 2012. A is still 2010. So 2012 is not less than 2010. So come to the next if. 2012 is greater than 2010. But is it less than 2011? Because B has now changed. 2012 is less than 2011? No.
No.
So no change will happen. Then, okay. Next row is 2013. Again, same thing will happen because A and B are not changed. A is still 2010, B is still 2011. So both these conditions will be again violated. So at the end, now that we have gone through all the years, right, we have to return B minus A. This question is a bit ambiguous, is it not? Because you need to mention what is A and what is B. Is it the year that we are checking year, but then where is the medal coming into play?
Ma'am, I
Year
think
gap between, okay. So it is asking B minus A. So in our example, B minus A is what? 2011 minus 2010. That gives 1.
Ma'am, I think the answer is the A is A.
I think year gap between first and second medal win by a player. Option A.
But let's say if this person hadn't won any medal in 2011, but he won 1 medal in 2012, 1 medal in 2013. In that case, where am I checking the medal? I'm not checking that anywhere, right? So I think the question statement is a bit ambiguous. This line assume that the player has won at least 2 medals and only one in any year. So does this mean that he has won at least 1 medal in every year or what? Like how are we supposed to understand this?
But the sentence is that he has the medal has to be only one, right? In any given year.
In any given year, you can score at most 1 medal.
Yeah. So if you are scoring at most 1 medal, so you cannot have 2 medals, right? So that
Yeah.
is the most you can have.
Yeah. But if we follow this, and if this is the case that 2010 and 11 he did not score any medals, but 2012 he scored a medal, 2013 he scored a medal. In that case, the year gap between 2 medals, the answer is A. So year gap between first and second medal won by a player. So that is not the answer here.
Yeah, because
We are not.
because the first and second case is not is false anyway.
This question is not good worded. It's very ambiguous. So what can we assume? If the player has won at least 2 medals and only one in any year.
I think both.
So if we take that he has won medals in all 4 years, then also it won't make a difference. So let's check the Olympics data set once. But it's like, let me share screen.
It's like 2 medal in his whole career.
So that
Yeah,
means
Hannah?
in some of the years he might not have won a medal, right? That is also
Yeah.
a possibility. Just let
Yeah,
me see the data, what the cards are like. Because I am not seeing that they are not checking for medals anywhere, right? They're just checking the year.
Hmm.
From the
So
year, how are you supposed to get the medal data? Whether
medal
he has
doesn't
won the
matter.
medal on Olympic. Yeah, this is Olympic. Okay, can you see? Oh, wait, I'll share. Nikhil Gupta, please close your whiteboard. Okay, I'll just share the entire screen. Right, you can see that. So this is the Olympic data set. So every card has what? It has a sequence number, it has the player name, gender, nationality, host country, year, sport, and medal. But in our question, it is saying that it is taking such a table where all the rows are about the same player. Right. All the rows are about the same player. But here you
And
see
also invert year.
yeah, these are all different players. So can it be that one person might have two rows here? Maybe they won another medal in maybe this first row, see, whoever this person is, Karnam. So maybe he has won another medal in weightlifting in some other year, right? So that will also be recorded in a different card. Because here this is the only information about one medal, this bronze medal in year 2000. But he could have won one more medal in a different year. Right, so we are taking all the rows for a particular player. But where am I checking the medal condition? That's why I'm confused.
Ma'am, from where did you get this question? Quiz.
This is a quiz question from I think 2023 or 24.
Ma'am, here I think they just want to know years between
But we are checking, see, we are checking B minus A as the return statement. So B minus A is just the subtraction between B and A, and both are storing some year, right?
Yes, ma'am.
So
Can you show the options?
yeah, this is the option. This is supposed to be the correct option, that year gap between first and second medal won by a player. So does this mean that we are only recording those rows for a player where he has won a medal? That means every year that is record for a player. That means that player has won a medal. That's why he is on record. Okay, so if I, according to that, if I change this and say maybe not take consecutive years,
मैम
let's say he
इसमें
won one. Yes, sir.
मैम इसमें जो ईयर और मेडल का जो रिकॉर्ड आएगा वो बराबर ही तो आएगा, तो अलग से मेडल काउंट करने की जरूरत ही नहीं है शायद.
But I think what we took wrong is that the year will only be recorded when in that year this player has won a medal. Only then. So 2010, let's say he won one medal. Okay. And then again in 2015, yeah, then this question will make sense. 2015, he won one medal. Let's say 2017, he won another medal. Let's not take a fourth row. If this is the case. Okay, then first we pick this row. So Z dot year is 2000. This is 2030. So B will be assigned to A, that is 2030, and A is Z year, that is 2010. Next if condition, Z year is 2010, A is 2010, this is violated. So move it to table 2, go for the next row, that is 2015. So now Z dot here is 2015. Is it less than 2010? No. So now come to this if statement. Is 2015 greater than 2010? Yes. And is 2015 less than 2030?
Yes.
Both are correct. So B will be assigned to 2015 now. Okay. Now, if I go to the third row, 2017, for that, will A or B anything be updated? Check. For 2017, it will never be less than the previous year, right? 2017 is a greater year.
Yes.
So 2017 will not be less than A, and 2017 will be greater than A, but not less than B. So after this, no matter how many times he wins a medal, A and B will not be updated. Right, A and B will remain. A will be the first year in which he won a medal. B will be the second year in which he won a medal. So if I get B minus A, it will give the year gap. So if I take B
Ma'am, it
minus
will
A at the
not
end of this,
satisfy the both if condition. The
No, it is
2017 year.
satisfying.
No, ma'am, the
Uh,
2017 year.
yeah, 2017, even if after this, if we have 2019 or any year after 2015,
Yeah.
okay, it will not satisfy any of the if conditions.
Yeah.
So B will always remain 2015, that is the second year in which he won medal. A will always remain 2110, the first year in
2010.
which he won a medal. Now, if we do B minus A, this will give us 5.
5.
So that is the year gap between the second and the first medal. Right. So that's why this is correct. But I think they should give
Can
more
you show the
information.
question above the
Because if someone is reading this question in exam hall, right? So all these ideas might not come to your head that, okay, every year he has won some medal,
Yes,
especially
yes.
when you are mentioning that only one medal in a year, right? So someone might think that way that, okay, maybe in some year they did not win a medal, still there is a record. So that's the thing that we should actually, the Olympics data set, the data set template will be given to you in your exam. So just by looking at the template, you'll be able to derive. But still, I would say this is a bit ambiguous.
Ma'am, but
Okay.
suppose we need to take those years only, no, where the
Yeah,
particular
So
team has won only
Olympic,
one medal.
no. Olympic data set actually, I showed you the data set, right? So every row is showing that a particular player has won a medal in some category, right? So every row in the table corresponds to one medal only. Okay, but a single player might have won more than one medals in different years. So for a single player, there might be more than one rows present in the Olympic data set in different years. Now, Olympic data set only has a row assigned to a player when that player has won a medal. No row will be such that, okay, this player participated in wrestling in 2010 but did not win a medal. No, there will be no such row. If the player has won a medal, only then his information is in the Olympics data set. Okay.
Yes,
So
ma'am.
for a
That's
particular player, all the rows will have at least one medal. At most also, at least. I mean, it is written here, only one.
yes, ma'am.
Okay.
That was my only doubt.
Okay. Everyone understood this?
Yeah, ma'am.
I also
Let
haven't
it be.
solved this paper before today. I'm also solving with you only. So whatever problems you are facing, I'll also face it. So following
Yeah,
pseudocode is
let's.
executed using words dataset again. So count is assigned 0. Then we have a while loop where we are checking all the rows of this words dataset, right?
Ma'am,
So
there
read
is
the
doubt.
first. Yeah.
B minus A. How did you get B minus A? How did you solve B minus A?
So at the end of all three rows, what was B storing? B is still storing 2015. A is still storing 2010. So that is the final value of B and A at the end of execution of this entire procedure. Table T1 is
B.
what? Just the rows of the same player. So if that player has only 3 medals, so 3 rows will be there. So at the end of execution, B is 2015, A is 2010. So you just take the difference. It is 5 years. That means there is a 5-year gap between his first and second medals.
Okay. So 5 years.
Yeah.
Ma'am,
So it is giving the year gap.
ma'am, if a
Okay.
player win only one medal in whole life, so
Then only one row will be there, no? Only one row is going to be there. So there is no question of getting a second medal. So there is
And
no
we
year
will
gap.
not take the player's data set. That player data set we will not take because it also said no, it at least 2 medals he should get.
Yeah, at least
okay,
2
okay,
medals. No, that means at least 2 rows must be there.
Yeah.
okay, ma'am. Thanks.
Okay, any other questions here?
No. This was tricky.
So this is on words dataset. What do you have to find? What will count represent? So count is initially 0. Then you pick the row from words dataset, read it, move it to table 2. I variable is set to 1, A is set to false, B is set to false. Then there is a while loop, inner while. So whenever we have inner while, that means some kind of comparison or something is going to be there, right?
Inner
Or
while
what is this
how
doing? Okay, in this case, what it is doing is it is
how
iterating
did
through all the
how
letters.
inner while how did you return from brackets?
No, actually what happens is whenever we need to compare two cards, like in that question we are comparing pairs of nouns. So pair means I have to take at least two cards and compare, right? That means inside an iteration there should be an inner iteration where we can pick one more card. So that's why I said that there might be some kind of comparison. But in this case, what they're doing is we are having a loop variable I, which is going to iterate
Your
until
voice
it
is
reaches the
cracking
letter
now.
count. Am I audible?
Yes, ma'am. We can hear
Yeah,
you.
it's
Yes.
cracking.
Okay, I think you can rejoin. Maybe some problem with your internet.
Okay.
So I is a loop variable which is supposed to iterate how many times until it reaches the x dot letter count. So whatever card you pick, whatever is the letter count of that card, it will iterate that many times. Okay, now inside what it is doing. Okay, let's take a word. Let's say the word on my this card is cloud. Okay. So in this word, what is the letter count? 5.
5.
So first I pick this card, read it, move it to table 2. I variable is set to 1, A is set to false, B is set to 0. So now I will iterate until it reaches 5,
5.
less than equal to 5. So I starts from 1. So if ith letter of X word is a vowel, ith letter means first iteration means it's the first letter. I value is 1. So 1 is C. First letter is C, which is not a vowel. So if condition will not be executed, you will go to the else part, line 13. Okay. So
Just a question.
here,
Just a question. Sorry. This if with bracket A, does this mean that it stores the value of A with if this condition is satisfied?
no, it doesn't store. See, if it was a vowel, right? So then it will go to the nested if. Here it will check what is the A value. So A was initialized to false. If false, that means we won't execute this if. If A value was true, then only I can execute.
Okay.
So, ma'am, in these types of pseudocode, we basically, if there's something condition like this, if A given under bracket, we need to assume that first of all, we need to make A true.
Yeah, only if there is it's like this if variable. That's all it's given. So that variable value has to be true for that if to execute. If it is false, then you cannot.
Oh, yeah.
Okay.
Yeah.
So in this case, C is not a vowel, so I won't execute this if. I'll come to line 13 else. A will be set to false. A was false initially only, but A will again be set to false. Fine. Then there is a I equals to I plus 1. That means now you go to the next. Okay, let's do the brackets once. This if closes here, this outer if closes here, this else will close here, and this closing is of the inner while. Okay. So now what is the next letter? Yeah. Asking something?
If we take the condition, if we check the line 8, what is it representing? What will take the value of A? Is it true or false?
That depends.
If we
At
get
this stage, at the first iteration, A was what? Initially, A was false. So
Yes.
if false means you cannot execute the if statement.
Okay.
So somewhere A will be set to true, only then you can execute if statement. After A is set to true.
So it means when we get the value, when we get the vowel, it represent true.
Let's see what happens when we get to the vowel. Okay. So when I increment I, then I get L. Second letter. So is the second letter a vowel? No. Again go to the else part. A will remain false. So you will increment I. Now I is 3. Third letter is O. Is it a vowel? Yes. Inside there is an if condition. So if A, at this point, A is still false. Right? A was never set to true. So you cannot set B to true. You will come to line 11. Now A will be set to true.
Okay.
Yes, ma'am.
Okay. After this, there is no point in going to the else part, right? You have executed if statement. So you will directly go for I equals to I plus 1. So increment I. Now I becomes 4. So 4 is U, which is also a vowel. Now if you check if A was set to true, now you can set B to true. Okay.
Okay.
So now B is also true. Then again you increment I is now 5. So is D a vowel? No. So go to the else part. Again set A to false. Okay. After that, I becomes what? 6, which is greater than the letter count. So we'll stop iterating. After that, what you will do is come to line 18. Now we are outside of the loop, this inner while loop. So for the first card, I have executed this inner while successfully for all of the letters. So now is B true or false at this point? B is true.
True.
Right. So if B, that means if B is true, then I will increment count. So now you tell me something. When is B being set to true?
When two consecutive vowels are
Correct. When
there.
there are two consecutive vowels.
Exactly
Even
one.
if there is one more, if let's say between the first vowel and the second vowel, if there is a consonant present, then A will again be set to false. Right. So B won't be true. B will only be true if you have consecutive vowels.
And ma'am, I see one more thing here, that once B is set to true, the count will also increment by only one only. And B will remain true if B is set to true.
Yes, once B is set to true, it will not be false again.
Yeah.
So B is representing what? That if for some word you see that B is true, that means you definitely know that in that word there are two consecutive vowels present.
Consecutive vowels, yeah.
Ma'am, can you
Right.
please repeat this question? I'm not
Ma'am,
getting it.
and ma'am, count will, the
Okay.
maximum value of count will also be one, no?
No, count is what? Count is going to store number of such words which have consecutive vowels in them.
Ma'am, the number of words will have exactly one consecutive pair of vowels, right? Because A will become false when it
So if
hits a
A becomes false, then let's say, okay, I'm just making an imaginary word. Let's say after this, if I have E and, okay, A, E, I, O, U, right? Just let's say it has
E and O.
two more vowels, E and O.
Yeah.
Then again, this E will set A to true.
True.
And then again, this O, so B will remain true. The point is that we are checking B, and once B is set to true, B cannot be set to false again.
Yeah.
Right. And so no matter how many pairs of such consecutive vowels you have in your word, if you have at least one such pair, B will remain true.
No, ma'am, I was asking that will the count will incremented if we get again two consecutive vowels?
No, count will increment only once for a single word.
Yeah, that's what I was asking.
Okay. Count for a single word only once it will increment if B is true. Okay, someone has to do this from the beginning once, right?
Yes, ma'am. Yes, ma'am.
Let's take the example of teeth, the word teeth.
Okay, sure. Okay. So initially, let me erase all it.
Ma'am, so like in the word teeth, count will only be incremented once because there's only one pair of consecutive vowels.
Correct. But even if there were two pairs, then also only once it will be incremented. For a particular word, if it contains at least one such pair of consecutive vowels, count will be incremented one.
Okay, because B will always be true.
Yeah, once it's set to true, it's not going to be false until the next iteration. Okay. But okay, let me check one more thing. Yeah, okay. Let's start. So if this is my word, okay, so this is X, right? So after I pick X, I read it, I move it to table 2. Then I initialize the variable I to 1, A to false, B to false. Now there is an inner while. This inner while will iterate how many times? Whatever is the letter count of the current word X. So for teeth, letter count is again 5.
5.
So inner while will iterate how many times? 5 times.
5.
So first I is initialized to 1. So for first iteration, I value is 1. 1 is less than equal to 5. So you enter the while loop. First if statement is checking is ith letter of X word is a vowel. So ith letter, first letter is T.
No.
Is it a vowel? No. Okay. So we won't execute any of this. We'll go to the else part.
Okay.
Else will do what? Else will set A to false again. A was initially false only, but anyways, A will be again set to false.
Okay.
Then you will increment I. So now I becomes 2. Again, next iteration is 2 less than equal to 5. Yes.
I become 2. I is already 1.
Yeah, then you incremented I. I was
So
initially
I
1.
must be 1 only, right?
2 incremented.
You
I
incremented,
plus
no?
1.
Yeah. Initially I was
Okay.
1, then you
1 plus
incremented
1.
it. So it is 2 now.
ठीक.
So what is the second letter? E. Is E a vowel? Ith letter?
Yes.
Yes. So now go to this if statement. If A, this will only execute if A is true. At
Vowel.
this point, A is false. So you cannot do anything. You come to
For
this line.
second letter, if condition is executing because it is second word is vowel.
Let's do it step by step. Otherwise, you'll get confused. So line 11, then I'll come to, and A will be set to true. Okay.
First
Now,
word
no need
was
to
not
do the,
vowel, so else is executing. Second word is vowel.
Ma'am,
so it is
please
executed.
change the value
Huh.
of A also with this iteration. Write A is equals to false, then
Okay.
change it. So
See,
that we,
first iteration A was false.
yes.
Okay. Now we are doing second iteration. Now A is set to true.
Hmm.
Fine. No need to do the else part since we already executed if. So
Hmm.
you just increment I. So I now becomes what? 3. So
Three.
third iteration. What is the third letter?
Next
E again.
vowel.
Vowel.
Is E a vowel? Yes. Now you
Yes.
check if
Again
A.
it.
Is A true? Yes. A was
Yes.
set to true. So now you can enter the if and turn B into true. Assign true to B. So in third iteration, what happens? A is also
4.
true. B is also true. Right. After this, you come to line 16 again. Increment I. Now I becomes 4.
4.
So fourth iteration. Fourth letter is what? Small t. So is it a vowel? No.
No.
To come to else part, A is again set to false. Okay.
Hmm.
Once A is set to false, so after fourth iteration, A becomes false, but B remains true.
Hmm.
Then you increment I one more time. It is 5 now. So fifth letter
Every
is
time
what?
we are
H.
implementing I, ma'am.
Yeah, I incrementing has to be done every time now because it is not inside any of the if or else statements. It's inside the while loop.
Hmm.
Ma'am,
Okay. Hmm.
so basically once B becomes true, it just remains true.
Yeah, once it becomes true for that particular word, it will remain true until
Okay.
we go for the next word.
B is true means which for which word?
For the current X words that we are using, this teeth word.
Teeth.
Yeah. So
Or
next I is now
A
set to
word.
5. So H is the fifth letter. Is it a vowel? No. So come to else part. A is again false. Increment I again, I becomes 6. But 6 is less than equal to letter count 5? No. So while loop will stop here. So now what you will do, you'll come to line 18. Check if at the end of execution of the inner while, what is the value of B? B is still storing true. So if B, that means if true. So we can enter the if block and increment count by 1. Then again, after this, you have to go for the next iteration of this outer while. That means read the next row, next word, whatever the word is. Then again, do the same procedure for that word. So
So it
when
is
is count
counting
getting
the
incremented? Count will only be incremented when B is true. And B will only be true when there are consecutive vowels, consecutive pair of
words.
vowels in the word.
Okay.
Okay, is it clear now?
Yes, ma'am. If B is not vowel, then it won't count.
Yeah. All right. Next question.
So what asked in this? Does this
It is
ask?
asking that what is count representing. Okay. So which option?
Vowels, pair of vowels, at least one pair.
Vowels consecutively.
Check the options
Number of
correctly. One is saying at least, one is saying at most. Which one?
Yeah,
Least one pair.
at least
Option
one
C
pair
is
of
correct.
vowel.
it would be at most
Option
3.
A, if I say that
A.
at least one pair of vowels occurring consecutively. That is enough.
Yes, correct.
Okay. So A is the answer. Now question 10. So given pseudocode is executed using Olympics table, what will count represent at the end of execution? So again, that Olympics data set. Assume that all players have distinct names. Okay. So first count is, what do we have to do? Count, we have to find out what it is storing. So count is initially 0. Now you have all the rows in your Olympics table, you know how it is like. For every player, we have that medal information, years, sports, everything. Now,
So it is representing.
read the first row. Okay, and then move it to table 2. This first card you read, move it to table 2, then there is an inner while. So you pick one more card. So this is a nested iteration. That means there is going to be some kind of comparison. So we pick one more card, row Y, and again move it to table 3. After that, you check whether the name is unequal. That is, the names in the two cards are not same. Right. In that case, you are going to check that, okay, why this is given? Why this is given that name is not same when it is already given that assume all players have distinct names? Because still for a single player, there might be multiple rows.
Ma'am, it is having nested iteration, no?
Ma'am,
Yeah,
because
nested iteration.
might have won more than one medal.
Right. So we will check for only those rows, those pairs of cards where the name is different. That means definitely the cards belong to two separate players. Right. So if the name is different on both cards, then we will go to the nested if and check if their nationality is same. They're from the same country. And if the medal they have won is also same. X dot medal is equal to Y dot medal. They have won the same medal. Okay. Now, if both are true, then you will increment count. So this if will close here, this if will close here, and this is the inner while.
Different
Right?
players from same nationality and same number of medal.
So different players from number of pairs of such players, right?
Yes.
What?
Pairs of players.
Pairs of players.
Yeah.
What players? Pairs.
You are checking two players, right? Two distinct players. For
Yes.
them, you are checking if the nationality is same and they have won the same medal. If both are true, then we increment count. So
Yes.
count is representing what? Pairs of players,
Oh yeah.
right? Pairs of such players that have the same nationality and the same medal.
Same medal one. Yeah.
So which option is correct? Number of pairs of players having the same nationality and same medal.
Yes.
Yes,
Understood?
ma'am.
And this is only 3 marks because this
Ma'am,
is
so the
pretty
option
easy.
C, ma'am, option C seems similar.
Option C is saying number of players having same nationality and same. Is it number of players? It is
Number
pairs,
of
right?
Pairs.
Pairs. It should be pairs. Yeah.
Yeah. Two people we are comparing. Na?
Yeah.
So since here you didn't have to do any iteration or anything, you just by looking at the condition you're able to answer. That's why the marks is a little less. Still 3 is a lot of marks. Now this is a 4-mark question. So it is saying the given pseudocode is executed using shopping bills dataset. So this is why I picked this paper because see all of the data sets are present, right? In every question we are covering some data set, unique ones. So shopping bills data set, everyone remembers what it has, customer information, whatever they have bought from which shop, all of this, right? So frac stores the ratio of number of customers who purchased both bread and I think we have done this before. Okay.
Yes.
Let's revise this one.
It was in the graded assignment one. Week 4 graded assignment.
So that's why I said that practicing the graded is good enough for quiz one, you know.
Yeah.
So let's still revise this once. If Prac stores the ratio of number of customers who have purchased both bread and milk to the number of customers who have purchased milk, we don't know if they have purchased bread or not. Okay. So choose the correct fragment of procedure has item to complete the pseudocode. Assume that there is at least one customer who has purchased milk. Okay. So frac is some fraction which is storing customers who have bought both bread and milk to people who have definitely bought milk. We don't know whether they have bought bread or not. So definitely this is the bigger set because there might be people who have bought milk but not bread. And then there will be people who have bought milk and bread both. Right. So people who have bought milk is the bigger set.
Yeah, so the numerator is the intersection of the two sets.
Numerator, okay, if you take two sets like this, that people who have bought milk and people who have bought bread, then their intersection will give you the numerator.
Yeah.
Okay, anyways, this M set is the bigger set. So M count is initially 0, B count is initially 0. Then while pile 1 has more cards, so from shopping bills, you pick one card. Then there is the if condition, which is checking if has item X comma milk. So what does has item do? So inside has item, what are the parameters we are passing? The card and the item milk. Okay. So what is it checking? Basically, it should check whether this person has bought this item or not. Right? Because see the rest of the code. If has item returns true for X and milk, then M count is incremented by 1. Okay. And if has item also checks true, sorry, yeah. If has item also checks true for bread, so this is a nested if. That means if M counts increments, only then there is a chance for B count to increment. That means B count stores what? People who have bought both milk and bread.
Milk and bread.
And
Yes.
M count will be people who have bought milk.
Only milk.
Yeah. They might have bought bread, we don't know yet. Okay. So M count is the number of people who definitely bought milk. B count is number of people who bought both. So what is the, and see, outside of this, once we have done this M count, B count, entire thing is calculated, then outside in line 12, we find that fraction. Okay. This is this fraction.
Ma'am,
So what should be, yeah.
just a quick question. So this B count stores only counts the number of breads only, right?
But it is a nested if, no.
भैया सो रहे हैं
If they have, but if they have
क्या हो गया
purchased
जग
milk,
रहे हैं कौन
only
चला
then,
रहे हैं ठीक है
okay, others please mute. All right.
हॉटस्पॉट कनेक्ट कर ही लिया होगा
Mukesh, can you please mute?
या मैम
So M count will be true if they have bought milk, right? And if they have brought milk, then only we will check the nested if.
Okay.
So when we check for bread, so we know that they have definitely brought milk. So B count is for milk and bread both.
Okay.
Okay. So our job is to find how does this has item procedure work? That is, how does it check whether this person has bought milk or not, bread or not? So for that, we have the code snippets. Let's check the first one. So they're saying has item first set C to false. It takes two things as parameter. One is your card and one is the item that you're checking, whether that person has bought or not. So first C is set to false. Now while card Y has more items. So it is going through all the items in that card. So you read an item Z from item list of card Y. If that item is equal to the item that you are looking for, that you have passed as argument, that can be milk or bread. If it is present for any of the Zs, then C will be set to true, otherwise C will be false. Right, and once you have checked for an item, you have to remove that item from the item list, so you don't repeat. So is this correct? You will return true if you find the item.
Ma'am, seems correct till now.
Yes.
Looks correct. So we will consider this as correct till now. Okay, let's see the other options. Here C is set to false, while card Y has more items. You pick one item, check. If the item you're looking for is present, then set C to true. Then remove that item and return C. This also looks correct to me. Because if we don't find that item, then C will remain false by default and will return false.
So, ma'am, the first option,
Ma'am, in this condition, it is removing that item, particular item list only. No, no, these two are the same only. Ma'am.
Yeah, these two are pretty
No,
same.
ma'am,
See, only
for
the
the
else
last,
part is not given.
yeah,
which is not
ma'am, for the
necessary.
last option, if the last item is not milk, it will, or the targeted category, it will be false right now for the
Yeah, if you
A
don't
option.
find that item in the item list, then C will remain false. That's why that else part is
But
not necessary.
suppose there is a item milk in the list, but it is not the last item, so
No, it
it
doesn't
will
matter.
be reset to
It can
false.
be anywhere. No. C is only set to false once in the beginning. Once you enter the while loop, C is never set to false again. Okay, so once you find the item, C will remain true from that point on. It's not about C. It's
For
not
the
about the
first
item
option,
being the
A
last
option.
item. Here.
For here we are setting C to false if we don't
Okay,
find the
yeah. So
item.
if here what the problem will be, so if we say let's say we found milk, A is milk. So we found that we set C to true, and then we found some other item in the list which is not milk. So at this point we are not returning. So we have to keep on going through all the iterations until item list becomes empty. So after this some item comes which is not milk, then C will again be set to false, even though milk is present. So at the end of the iterations, C might be false.
Ma'am,
Right.
I'm not able to understand.
See, if the person that we have, let's say he has brought some items A, B, and then milk, and then D, some other item. So we are checking if this person has bought milk or not. So our A is basically milk. Okay.
Yes. Yes.
So these are three are some other items. Okay. So when we go through the item list, we are going in this order. So first we are checking with the first item. No, it's not milk. So C, it's false. B is also not milk. C is false. Then we find milk. C is set to true. But once we find C to be true, we are not returning it, right? We are not returning C at that point. We'll return C after the item list is empty. So we have to go for the next item also. Now, when we check next item and it is not milk, C will be reset to false here
So it
in
might
the
not
else
be
part.
counted at all. That's why.
So this will only give true if the item is at the end.
Okay, that's why it's wrong.
Yeah, this is wrong. Even if it looked right at the beginning, but this is a very good point. That this is the trick of this question, that you will miss this else part. That there might be other items after milk. So this is wrong. This looks correct. Let's see the other ones also. Here this is true. And then we check all the items again. So what is the difference between these two codes?
C is initialized wrong.
C is true.
C is set to true. So even if we don't find the item anywhere, C will still return true.
Still true.
Right. So this is also wrong.
This is completely wrong.
Yeah. This one also C is set to true, but still let's see because it is returning not of C.
Not.
Okay. So if C is true, okay, let's say I did not find the item, then it will return false. But what if I did find the item? So then it is setting C to false and not of false will give me true. So is this correct?
Yeah.
So B and D are both correct. Okay. This D option, is anybody having any doubt? Okay. So A is wrong. This is a very smart observation. Very good. And
So can I just recap? A is wrong.
The question was to pick out the incorrect one or what?
now question is to pick out the correct one, which is the correct has item procedure. So B and D are both correct.
B and D are both.
Yeah, B is correct, we saw.
Yeah.
Then D, even though C is initialized to true, we are returning not of C. So let's say C is true. We did not find the item in the card item list. Then we will return not of C. So not of true will be false. We are returning false anyways. But if we find the item, if we find milk in his item list, then C is set to false. Right? Once it is set to false, it is never set to true again. So when we return not of false, it will return true. So both these procedures are correct.
Ma'am, can you repeat why first
One
option
thing
is
also, ma'am,
wrong?
we discussed option A. That option A also looks like it is correct.
No, option A is wrong. Why? Because let's say this person has bought some. Okay, let me create an item list. Let's say he has bought shirt, then some orange, and then he has bought milk, and then he has bought a pen. Okay, this is the item list 1, 2, 3, 4. We'll go in this order. So let's say C is initially false. So you pick the first item, shirt. Is it the item you're looking for? You're looking for milk. So Z dot item is not equal to milk. So you'll go to the else part, set C to false. Then remove this from the item list. So for the next item, check oranges. It is not equal to milk. Again, C is set to false. Remove it. Then third row, you find that yeah, this person has bought milk. So C is set to true, right? And you remove milk. Then you have the fourth row also because still you haven't reached the end of the loop and return statement is at the end of the loop. So for pen, when I check, it's pen equals to milk. So that will be wrong. So again, C will be set to false. And then you will return the false value, even though milk is present in the item list.
So this will only work if milk is at the end.
Yeah, if the item we are looking for is at the end of the item list. Right.
Okay,
only then this will be true.
Yes, ma'am. Thank you.
Okay. Okay, this is easy question. So it is saying given information represents words dataset, it may have some mistakes with respect to sanity of data. This is from your week 1 content. Okay. You have to identify all rows with mistakes. So first row is saying card number and the value is given as XYZ. Is this correct type of value? Can card number be a string?
No.
No.
So this row 1 is wrong, incorrect data type.
The row 4 also.
Then row 2, okay, let's go one by one. Word. The word should be a string, but here a number is given. So row 2 is also incorrect. Part of speech is noun. This is fine. Noun can be a part of speech. Letter count, can it be negative?
No.
No, ma'am.
So other than row 3, everything is wrong. Right. So which of the options? Row 1, row 2, and row 3. Now row 3, there are two things given. Incorrect data type, invalid value. These things both are wrong. So C and D are not the options. Row 4, it is saying incorrect data type of letter count or invalid value of letter count. Which one is correct?
Invalid value because
Because
data
it
type
is an integer. It is an integer, right? Yeah, but the value is wrong. So F, A, B, and F. This is clear for everyone?
Yes, ma'am.
Ma'am, the D also, no, ma'am. The D one.
D is saying
Invalid
row
value.
3 is invalid value of part of speech.
No,
But it is
invalid value.
part of speech value can be noun, no?
Yes. Invalid value, no, it is correct.
Now question 13. Now this is also on scores dataset. At the end of execution, count captures what number of pairs of students having either same gender or from the same city, but not both. But the pseudocode may have mistakes. So we have to identify the mistakes. Okay, now we have to assume that whatever statements are not in the listed options, they are free of errors. So this type of question in exam, what you can do is just go through the options, okay, so that you don't have to check every line. So option has lines 13, 18, 20, and 21. So these are the 4 lines where there is a possibility of a mistake. So we have to focus on these lines. So first let's go through the code. What do we have to find? Count should capture number of pairs of students having either same gender or from same city but not both. So initially count is 0. Now you go through each of the cards. Read the first card, move it to table 2. Again, you have to pick one more card, right? Because we need pairs of students. So we have to compare 2 cards. So you pick one more card in this line 5 inner while loop. Then you check that you read this card Y, move it to table 3. And then you execute this find pair procedure where you put both of these cards as arguments. So what does find pair do? So it is setting A to false and B to true initially. Okay. Then gender, if it is equal for both cards, then A will be set to true. If city town is also equal, then B will be set to true. Now, if condition is checking A and not B. Okay. So let's say, what is our condition? That the only time we are not going to take it into account is when both conditions are true. That is, both A and B are true, right? One of them has to be true, not both. So what happens if both are true? If A is true and B, not of B we are taking. So if B is true, then it will evaluate to false. True and false will give false. Then there is another expression, not of A. This will give false. And B, even if it's true and false will again give false. False and false will not return 1. So this is okay. Now let's see one more thing. If let's say the this one is correct. Okay. So gender is equal, but city town is not equal. But B is initialized to true. So it will remain true. So even if gender is equal and city town is not equal, that is our condition is valid. One of them is true. Still it is not going to return 1. Am I clear?
Ma'am, so you're saying B, it's okay for B to be initialized?
No, it is not okay for B to be initialized to true. That's what I'm saying.
Yeah, okay.
If B remains true, then even if city town is not equal but gender is equal, still both of A and B value will be true.
Okay.
Right. And if both A and B are true, then this expression will evaluate to false. So it will not return 1. So line 13 is wrong. Let's see if it is in the answer. A is there, line 13. It is wrong. Okay, next C. If we change line 13, okay, what else can be wrong here? Okay. So definitely here nothing is wrong, right? This part. Because we have seen that what are our options? 13, 18, 20, 21. Okay. So out of these now 3 more lines are remaining for us to check. 18, 20 and 21. So 18, it is saying incorrect update of B. Okay.
It's fine.
But this is a correct update. If B was initially set to false, right, then it should be set to true when the city town is equal. So it is fine. Line 20, it is saying if A and not B and not A and B. So line 20, is this correct? The option is saying it is an incorrect condition. Now, when is this an incorrect condition? Let's say if A and B are both initially false. Okay. Now we found such a card where the gender is equal, so A is set to true, and the city and town is not equal, so B will remain false. This is saying that we have fixed line 13 after that. So in that case, A becomes true and B becomes false. Right? Now if I apply this condition here, it should return 1. So A will be true, not of B will be true. Not of A will be false, and B is also false.
Ma'am, so it should be or no. I know. It should be and.
If we need to fix this, since this is an or, yeah, this should be an or.
Yeah,
If
between
we
brackets,
change this
it
to
should
or,
be or.
then
Because
it will be correct.
the A
Because
and
then any of the condition will be true, na? Then it will return true.
okay, ma'am.
That should be the case, that either A and not B or not A and B. Both of them cannot be true at one time, right? This is so virtually impossible, because how can both conditions be true at one time when you're taking negation? So this, if we don't fix, then even if the conditions are true, still it will return false and it will not return 1. So line 20 is also wrong. Line 20.
Can you repeat this question once?
This particular line?
No, ma'am, full question.
Okay, first let me check what is the option D still. Okay, line 21, it should return 0. No, line 21 should return 1, right? If the conditions are satisfying, it should return 1.
In order to increment count.
Yeah. So that way we should be able to increment count. So line 21 is fine. So 13 and 20 are the wrong line. Okay, I'll tell you this again, what is happening here. So we need count variable to store the number of pairs of such students who have either the same gender or who are from the same city, but both should not be true. Okay. So now the pseudocode has some mistakes. That's what we have to find. So since we are having pairs of students, so we need to compare 2 cards. That means there will be a nested iteration. So this is the outer while loop. So you pick one card X, then you pick one card Y in the inner iteration. Now inside count, you are writing count plus find pair XY. So this find pair XY is the procedure where the control will shift now. Okay. So if it comes here, let's say I have picked a card X, okay, and I have picked a card Y, and such that X and Y have the same gender, but X and Y city town is not equal.
Okay.
For example, so now if I go to find pair XY, line 13 initializes A to false, B to true. Okay. Now, if gender is equal to Y gender, then A should be set to true. So in this case, in my example, gender is equal, A is true.
True.
Then in the next one, city town, if it's equal, B should be set to true. City town is not equal, but since B was initially true, so it will remain true.
True.
Okay, then if I come to line 20, okay, and now I put these values. So A and B are both true in my case, right? So this is giving what? A is true
and not B.
not B. That is
Means
false.
true.
No, B is true, no? B was
Not
initially,
B.
so
Yeah,
not of B is false.
not of
Not
B.
of
Okay,
not of
okay.
true is false, right?
B is true, so not of true is false.
Yeah.
Ma'am,
Similarly,
and function shouldn't like both be true in order.
yeah, I know. I have taken this example, so I'm going with it. Next example, I'll take one such where both are true.
Okay.
Okay.
Not A.
So here, if I go not of A is
False.
initially A
True.
was set to true, so it will be false now. B will be
No,
true
A
only,
is false, right, initially.
but it was set to true, right? Since gender was equal. In my example, gender is equal. That's what you checked in the if condition. If gender
And
is equal, then A is being set to true.
okay. And B is true already.
Yeah. So what does true and false give? False. Here also
False.
true and false gives false. So false and false will give false. We won't return 1. Okay.
Why are you minusing? Subtracting?
No, I'm not minusing. This is just a sign. So false and true, true and false. Both are giving false. So false and false will return what? False.
Hmm.
So if false means I cannot execute this statement, return 1. It will return
Okay.
0. Even though my
Hmm.
condition was correct. My
Yes.
condition is correct. One of the
Yes, yes.
gender condition is okay, but city condition is not equal. So it should have returned 1 ideally, but it
Hmm.
didn't because of this wrong initialization.
Hmm.
So line 13 is wrong. Okay. Now if I did set this to false,
Now this will initialize 1.
so if I set this to false
Return 1.
and I keep this same card, okay, then what will happen? Both are false. Okay.
False.
Now let's take something. If gender is equal, then A is set to true. City is not equal, right? So B will remain false. Agreed?
Hmm.
Then if I come to line 20, so line 20, A is now true, B is false, not of false is true. Not of A is true, not of true is false.
False.
And B is already false.
Hmm.
So true and true will give true, false and false will give false, true and false will give false.
A
Right?
is true and B is not. B is also true. For first one.
No, I initialized B to false, na? I fixed this line 13 now.
If you initialize B as false, then B must not be, which is true. Okay.
Yeah, this one is true, but B itself is false.
But in last condition, you stated as false.
B I set to false initially. Okay.
Yes.
But now I have fixed the code. But I saw that this condition is false. 3T town is not equal. That's why B was never reset to true. B remained false. A was set to true. So now you just put this true false values in this line 20. Putting this, I get true and false, which will evaluate to false again. So it won't return 1. It will again return 0. That means something is wrong with this statement, line 20.
This is also wrong.
So it will be correct when we change this and to or. So then true or false will give true. Right? Because at a time, either this bracket can be correct or this bracket can be correct. Either A and not B can be true or not A and B can be true. Both cannot be true at a time. So and is not the proper statement here, or should be the proper statement. So both line 13 and 20 have errors.
Okay,
Here.
thank you.
Yeah. So A and C is our answer.
Ma'am, can we move to question session? Doubt session?
Yeah, just one more question is left. Let's do this. It's an NT type. Then we'll take the doubts. Okay.
The math session is started, so that's
Okay,
why.
okay. Tell me what doubt do you have?
I have doubt from activity question 4.4. Question number, I have solved the question number 1, but question number 3 is a little tricky and I have solved it multiple times, but still I'm not able to find the answer, right answer.
All right, let me open that.
I have sent you the screenshot as well.
Yeah, it's okay. I'll
Or
just
even it
open.
will be better, actually, I have not understood the binning method actually very clearly. So it would be great if you...
Binning, you
ma'am.
have to give some time. Okay, let's see. Which activity did you say? 4 point?
Ma'am, you can explain it with question activity 4.4 and question 1, 2, 3, 4 all related from each other. So you can
This
explain.
one. Okay.
Yes, ma'am. I have solved the one. It's 190.
Look,
And when I'm
binning
solving
means
question,
what? That if I have a number of n number of objects, okay. So what is the, if I want to compare every object with another, then what is the total number of comparisons that I'll get?
n times n minus 1 upon 2, right?
Upon 2, correct. So that is the first question. How many pairwise comparisons we need to make if each object is compared with every other object? We have 20 objects. So
20 times
20
19
into
upon 2.
19 by 2.
Upon 2, yes, ma'am. Yeah.
So that is 190. Next, it is
Yes.
saying assume that we can distribute the 20 objects into bins of equal size. So this is binning. Binning is done why? To reduce the number of comparisons. Okay. So if we have n objects and we divide them into, let's say I have 9 objects and I divide them into 3 bins of equal size. So
Ma'am,
each
ma'am,
bin
ma'am,
will have
please,
3 objects.
don't, this was the confusion actually. Professor also took 9 objects and divided into 3 bins, and each bins has 3 objects, right? So
Yeah.
it will be more clear if we took 12 instead of 9 and then divide into 3
Okay,
bins.
let's take 12 objects, each has 4. Okay.
Yeah.
Now inside those bins, only those 4 objects are comparing within themselves. Okay. So you calculate, if I didn't do the binning, then how many comparisons will I need? 12 into 11 by 2.
9
That is
times 2.
132 by 2, 61. Right.
Okay.
That's correct, right? Just you calculate one more time. I think it's 61. Okay. Now if I divide them, that is 3 bins, let's say having 4 objects each. Now inside each bin, how many comparisons are there? 4 into 3 by 2. So 12 by 2, that is 6.
6.
How many such bins are there? 3 bins.
3.
So total how many? 18.
18. Yeah.
So your comparisons reduced from 61 to 18. This is the impact of binning. If someone asks you what is the factor by which the comparisons has reduced, you'll say 61 by 18. Okay, this is the binning factor. Total number of comparisons before binning, so the total number of comparisons after binning. Okay, now let's do question. Yeah.
Just a quick question. So the factor by which it reduces is 1 by k, right?
No, factor is k is what? The number of bins, no?
Yeah, exactly.
It is number of, there is this formula, I don't exactly remember it, but the formula is that a number of comparisons without binning by with binning.
Yeah, okay. Yeah, sure.
Okay. So you check that slide once, there it is given. But I don't memorize this formula. So,
Ma'am, I
okay,
have opened it. Still, if you want, I can share it to you.
Yeah, it's okay. Let's first solve the questions. Okay. Because we know the theory.
Yes,
So
ma'am.
assume that there is no point in memorizing this formula. Okay. Just knowing that n into n minus 1 by 2 is enough. The rest of it you can derive. So assume that we can distribute the 20 objects into bins of equal size. If we go with 4 bins, how many comparisons will we have to make? So 4
Yes.
bins, 20 objects. Each bin has how many? 5 objects.
5 objects.
So
Yes.
inside each bin, how many comparisons? 5 into 4 by 2.
520 upon 2,
That is
10.
10. So
Yeah.
4 bins, each having 10 comparisons, total 40 comparisons.
Yes.
Okay.
40.
Third question is saying if we distribute 20 objects into bins of equal size, how
This
many
is
bins
easy,
should
ma'am.
we?
I solved it. Yeah.
Yeah.
It's just I can compare one to other. Was only once.
Least number. That means you can take 10 bins with 2 objects in each. So there will be only one comparison in each of the bins.
Ma'am, it's always
Ma'am,
easier to
third
say
option.
we divide the all objects by 2, and that's the number of bins.
Yeah, that also you
for-
can do. That is, I mean, minimum comparison will occur when you have only 2 objects.
Yeah,
Ma'am,
just
for
divide the
third,
whole object by 2.
Yeah.
ma'am,
So
for
fourth,
third question,
hmm,
n into n minus 1 by 5, it means 20 are there
no,
if we divide into
that is
bins.
total. See, 20 objects, it is asking how many bins should we choose to make the
5,
least number of comparisons overall.
5.
So least number will happen when? If we take 5 bins, then each of the objects, each of the bins will have 4 objects in it. That is still a lot more comparisons. Least will happen when you compare only 2 objects at a time.
We have to take 5 bins. Inside
We have to
one
take
bin.
10 bins. Least
Can you
number
explain?
will happen, least number of comparisons will happen when we compare only 2 objects at a time. So 2 objects, if I compare in one bin, if I have 2 objects, what is the number of comparisons? 2 into 1 by 2, that is 1.
Yes,
So if I take 10 such bins, each having 2 objects, so total 20 objects,
20.
each bin has 1 comparison. So minimum is 10 comparisons.
Okay, that's all.
Yeah. Now, fourth question is saying based on question 1 and 3, by what factor does binning reduce comparisons? So you just do 190 by 10. Right. 190 is
What?
190 is what? Number of comparisons without binning. Factor
Yes.
means what? Number of comparisons without binning by number of comparisons with binning. So 190 by 10.
Yeah. I have found the solution, but the problem is what professor has told. The only the formula of without binning is working. I applied with question number 2 the formula using binning. The my question is 67. I don't know why. If you wish,
Yeah,
I can share
because
the.
in question 2, you're using 4 bins, na? So the binning factor will be different. Binning factor will, the factor of reduction will change according to how many bins you are using.
Actually, the formula that professor has told in the lectures, I use that formula, and that
Okay, you
using
share
that
the
I found
formula.
that. Yes, ma'am. Just a second. Just a second. It will be even better if you explain both the formulas.
Okay, you share it, I'll explain. Or you tell me which slide I can get it.
I have notes. I have taken it. So just a second. I just sent it, ma'am.
In the chat?
Yes.
Okay. Is my screen visible?
Yes.
Okay, let me rotate. This, right?
Yes, ma'am. Ma'am,
Yeah,
please
so
explain everything on this slide. Actually, only if you the first formula I know. Otherwise, rest are not working as expected. I mean.
look, this n into n minus 1 by 2, you know, right?
Yeah.
And this nc2 is just another way of getting that same formula by combination. So
Yes,
from
it's just same thing.
yeah, same thing. NC2, you just have the combination in factorial, that formula, if you put it, it will give the same result. So from first principle, it is saying that total number of pairs is n cross n. If I have n elements, how many pairs can I have? N cross n pairs. If I have 5 elements, how many pairs can I have?
25.
25 pairs. So 5 cross 5. So like that, if I have n elements, n cross n pairs I can have. Right?
Yes.
One second. Next, it is saying from this reduce self comparisons. So obviously we want to compare with other objects. If I have an object A, I want to compare it with B, C, D, not with itself. Right? So this n cross n comparisons also contains the self comparisons. So we have to remove them. So if I have n objects, how many self comparisons will I have?
5.
If I have n objects, then I'll have n self comparisons. If I have 5 objects, 5 self comparisons. Right? So we have to remove those self comparisons from this n cross n. So n cross n minus n. Okay. N cross n minus n if you do, now just take n common from here. What are we getting? N minus 1, n into n minus 1.
Yes.
Okay. Now why are we dividing it by 2? Because in this n cross n, number of pairs that we had, or currently it is, since we removed the self comparisons, it is n into n minus 1. Now inside this n into n minus 1 number, we have such comparisons like A is compared with B. Okay, this is one comparison. Again, B is compared with A is counted as another comparison, but these two are same, right?
That's why we are dividing it by 2.
That's why we are
Hmm.
dividing the total number by half. Okay,
Hmm.
we are multiplying it by half. So
Yes,
n
ma'am. I
into
have
n
sent you
minus 1 by 2.
another slide. Actually, that's binning one.
This is only showing in my chat. Okay. No, I can only see this picture at the end.
Okay, let me send it again. Have you received, ma'am?
No, I can only see these. Have you sent to someone particularly, or you just sent it to everyone? Okay. Then only I will be able to see.
Send to send to everyone.
Wait. Yeah, now I got it.
Okay. Maybe my internet was not working well.
This one, right?
Yes, ma'am.
Okay, see. So 9 objects, this part, did you understand? Do I just take this calculation of reduction due to binning? This part do you want?
Yeah, I know this. You explained it earlier. The problem was actually professor used 3 bins, each having 3 objects.
Yeah,
So
always
that's why.
bins will have equal number of objects only.
No. Actually, 3 bins and 3 objects. I was confused there when I started. I
So that is
mean,
fine. This will work for any, okay, any number, n number of objects, but you must make sure that if you have k bins and total n items, then each bin should have how many items? N by k, right?
ma'am, just explain the second slide. Calculation of reduction due to binning.
Look, for n items, number of comparisons without binning is how many? N into n minus 1 by 2.
By 2,
That is
yes.
what is written.
Hmm.
Now, if we use k bins of equal size, okay, so k is the number of bins, each can only have same number of items in it. Like this 3 bins having 3 items each, like this.
Yes. Okay.
K bins of equal size, number of items in each bin then will be what? N by k. Like there we had
And
9 by 3.
yes. So that will
N by
be
k.
each bin will having each equal
Yeah. So each bin
objects.
has how many items? N by k items.
Yes.
So number of comparisons inside every bin is what? Inside a particular bin is now. So take that same formula, n into n minus 1 by
Summation
2.
of all.
See, inside a particular bin, how many comparisons are there? So still the
N
formula
times
is
n is.
same, n into n minus 1 by 2. But now
Yes.
n has changed. N is n by k now, because in each bin I have n by k elements. So just in
Sorry,
place of
I
n,
didn't
you
get it.
place, okay, look, n items if I have, the formula is what? N into
N
n
times
minus
n
1 by
minus
2.
1 by 2. Yeah.
So if I have n by k elements, what will be the formula?
N by
N by
k
k
elements. N by k times n by k minus by 2.
minus 1 by 2. So that's the
Yes.
thing that is written here. Half into n by k into n
Yes.
by k minus 1.
Yes. Okay, I got this.
Okay, then what will be the total number of comparisons? If I have k bins, this half into n by k into n by k minus 1, this is for one bin. If I have k bins, just multiply by k.
Total number of comparison means I'm not getting this one.
Total number of comparisons among all bins.
Yes. So how, I
Just
mean,
multiply by k. You know how many comparisons are there in each bin. This n by k one. Half into n by k into n by k minus 1. This is for one bin. So if you have k such bins, then how many comparisons will be there? Just into k.
into k, yes.
So that's what's written here. Then if you reduce this, that means some cancellations will be there. Then it will come up to be half into n by k minus 1. So
Ma'am,
this cancellation,
yes, ma'am. The formula for total number of comparisons using binning is half of n times n upon k minus 1, right? So can you okay first explain this and then please use this formula to
there
solve
is no
question number
need
3.
to memorize this formula. I just use this formula without writing all of this, right? This is the exact thing I did, just not writing the formula. No need to memorize it. Just understand what it represents. You don't need to remember half into n by k minus 1. This much is not required. What we know is if I have n elements and if I have k bins, this is what all you need to know. N elements, k bins, each bin should have equal number of objects. So if each bin should have equal number of objects, what is the number of objects in each bin? N by k. Right? Inside each bin, how many comparisons should be there? Just that same n into n minus 1 by 2 formula. Instead, now you have, instead of n, you have n by k objects. So replace n with n by k. Right? This is number of comparisons inside one bin. If you have k such bins, just multiply it by k. In an actual problem, this n and k value is known to you. Right? So you don't need to memorize this formula. It's just going to take up your memory, that's all. But yeah, if you want to memorize, you can. That is half into n by k minus 1. Then factor of reduction, see, this is again another formula. So you already have enough to memorize. That's why I say that don't memorize this sheet. Factor of reduction is nothing but total number of comparisons without binning. So if I have n objects, what is the total number of comparison without binning? You know that. N into n minus 1 by 2. Right? And what is the total number of comparison with binning? That same thing that you
n by
just
k
found out.
times n by k minus 1 by 2.
Yeah, into k. Because
Into
total
k,
k
yeah.
bins are there. So just put that in the denominator. Now, if you cancel these out, you will get something like n minus 1 by n by k minus 1. Again, if you want to memorize this, that is your choice. But in
It's so
actual
simple
exam,
that we have to only memorize n times n minus 1 upon 2.
just one
And
formula is enough. Yeah, n into n minus 1 by 2. Then you can
when I
manipulate
found the formula
for any
using
number of
binning,
bins.
and yeah, we can divide it to know the factor of reduction.
Exactly. So factor
Okay,
of
but
reduction,
actually,
just remember this much, that numerator should be number of comparisons without binning, denominator should be
without
number of
binning,
comparisons with binning.
with binning, yes, ma'am. Okay, but ma'am, why formula 1 is not working in question? I mean, why?
Which formula?
Both factor of reduction and total number of comparison.
Yeah, it is working. Why not? Where is it not working? Which question?
In question 2, right? Using binning.
Yeah, so what is question 2 asking? How many comparisons will we have to make overall if we put them into bins of equal size? 20 objects into bins of equal size, if we go with 4 bins. So now your n is 20, k is 4. Right?
Ma'am, like this I can solve it actually, but using formula, please
Yeah, now you have
substitute
n
the.
is 20 and k is 4. So put this value in your formula. So first find out what is. Wait, let me write it. So I'm
Ma'am,
just
k
writing
is
it
4,
here.
k is 5.
Why? It is given 4 bins.
So k will be equal to a number of elements in one bin, right?
Is k number of elements in one bin or k the number of bins?
I don't know.
See your slide that you sent me. K is the number of bins.
Ma'am, I have sent you, no?
See, if we use k bins of equal size.
Okay, k is just bin, number of bins.
Yeah.
Okay.
So now you put that in this formula. If I write it, I'm just writing it here. So my n is 20 and I know I have 4 bins. So my k is 4. I need to find
4.
total number of comparisons using binning if there are 4
Bin.
bins.
Yeah.
So I will first find how many comparisons in each bin. So half into your formula is n by k into n by k minus 1. Correct? For one bin.
Half into n times n by k minus 1. Yeah.
So just put the values here. N by k is what? 5. 20 by 4. Into 5 minus 1. That is 4. So 5 for the 20 by 2, 10. Now you want to find for all bins.
Ma'am,
So 10 into k.
Ma'am, n by k is equal to 20 upon 5, right?
20
Why you
upon
have
4.
written
Where
5?
are you getting 5? I have 4 bins. N by k gives the value 5.
Yeah, 4. Huh. So it will be equal to 5.
So 10 is for one bin. You have k such bins, so multiply with k. What is your k? 4. So 10 into 4 for the comparison. Clear?
Ma'am, the formula is 1 by 2 into n into in bracket n by k minus 1. This is the formula
Okay,
only.
fine. You want to put that formula exactly fine. Let's put it. If I just multiply k here, right? This is the formula. Happy? So
Ma'am,
if I do
1
this
by
multiplication, listen to me. If I do this multiplication, k will get cancelled out. So what are you left with? 1 by 2 into n by k minus 1. This is the exact formula, no? So you want to put the value here, you can do that also. What is n? 20. What is n by
20.
k? 5. 5 minus 1 is 4.
5.
So 10 and
yeah.
2 and 20 if I get cancelled out. So 10 into 4 is still
10,
40.
40. Yes, ma'am. Okay, thank you.
Okay.
Oh.
Okay, it's the last question. Question 4 is clear, right? Factor of winning. 190 by 10.
Just divide the 190 by 40.
190 by 10 based on questions 1 and 3. In
1
question
and 3.
3,
Oh.
we have 10, right? So 190 by 10.
Ma'am, one second. Why we are dividing with 10 and not by 40? Because it's just without binning and upon binning, right?
No. In both cases, question 2 and 3, both cases we are using binning. In question 2, we are using 4 bins. In question 3, we are
No, it's
using 10 bins.
specific to question 3, yes.
Yeah, it's specific to question 3. Okay. If we
Okay,
did
then
for question 2, then
190
it will be 190 by 40.
40, yes. Then, ma'am, it will be in decimal form, right?
Yeah, that is not a problem. It's okay. You can take the ceiling value.
Okay. Thank you, ma'am.
Yeah. Okay, so should we discuss this last question? Or do you want to stop? Up to you. Right. Just let me check. Okay, I think a lot of people have left for other classes, so I won't continue this. Okay. So tomorrow's session, you can ask the rest of your doubts, whatever it is. I think we have pretty much covered all the concepts from week 24. All right. Thanks for joining, everyone. I'll close the session.
Thank you, ma'am.
Yeah, thanks.
Thank you, ma'am.